All right, our next unit that we're going to cover is section 7.6. This is graphing systems of linear inequalities. We've already graphed linear inequalities on one line. This is graphing systems on a line. And systems of inequalities is when you have two or more inequalities relating the same variables. It's just like a system of equations. The only difference is these are inequalities. And we know they're inequalities because we've got the greater than, less than, or less than or equal to, greater than or equal to. And the solution to a system of inequalities, that's when all ordered pairs, okay, so this is the solution, is when all ordered pairs of numbers that satisfy that each inequality in the system. So basically it shades in, or it shows you every possible solution for both systems, for both equations. That's for the system. And when we go to solve a system of inequalities, here's what we do. First thing is we graph each inequality. We learned that in the last unit. And we do that, they do them on the same plane. Just like when we were solving systems of equations by graphing, we graph both lines on the same plane. Same thing with inequalities. We're going to graph both inequalities on the same plane. And we have to graph the line, test a point, and shape. That's part of the graphing of the inequality. So there's a lot more work to it. And then the solution of the system is where all the points in the regions in the graphs overlap. And this is also a double shaded region. And what I do is I shade the solution really dark. Okay, and for purposes of the notes, what I'm going to do is I'll do each inequality in a color. And then what I'll do is I'll do the system or the solution in a different color or really dark so that you can see what the actual solution should look like. Okay, we're going to start with example 1. We have two lines here. I'm going to start with this inequality. Okay, start with the line part of it first. This is in slope-intercept form. So my key features are my y-intercept is 3 and my slope is 2. Just ignore the inequality for just a minute and think of it like an equation. I would graph the y-intercept and the slope. What you need to pay attention to with the inequalities, remember that if it does not have an equal to sign, it's a dotted line. And I go ahead and write that down so I'm reminded that my line is going to be dotted. And then you choose a test point for that equation, or that inequality. And I usually test 0, 0. As long as it's not on the line, it's a really good one to test, and it's really easy to plug in and look at. So for this first one, if I test 0, 0, I've got 0 is greater than 2 times 0. I'm plugging in 0 for x and 0 for y, plus 3. So if 0 is greater than 3. And what you do is you ask yourself, is that a true statement? Is 0 greater than 3? It's not a true statement, so I do not shade that point. And I shade on the opposite side of the line. And look, I write all of that stuff out before I even plot anything, before I even graph, so that I kind of have an expectation of what I'm graphing. Okay, so my line is going to be, my y-intercept is 3, my slope is 2. Remember, if it's a whole number, it's like it's over 1. Rise over 1, we're going to go up 2 and over 1 from that point. So I'm going up 2 and over 1, and I go a couple of different times. And before I draw my line, I check to see if it's dotted or solid. Because there's no equal to sign, it's a dotted line. Remember that from graphing inequalities in the last unit, in the last section. And so I just go ahead and make it dotted. Okay, that's important. If you draw a solid line, you're going to get points off for that. And then I have to decide which side of the line I'm shading on. So to decide, I look at my test point. My test point that I pick is always 0, 0, and I do it in red so I can remember where it is. For this line, I said I do not shade that point because it does not make the inequality work. So that means I shade on the side opposite of that. So I'm going to shade on this side of that dotted line. Okay, so that's the first one. Then I do the same thing with the second one. I'm going to graph it using my key features. Since this is in standard form, my key features are going to be my x and y intercept. So that's when I do my table. I plug in 0 for x and I plug in 0 for y. If I plug in 0 for x here, I get 4y is 12, divide both sides by 4, my y is 3. Don't worry about the inequality for the purposes of the intercepts, we're just getting the graphing points. And then if I plug in 0 for x, if I plug in 0 for y, I just did 0 for x. If I plug in 0 for y, 4 times 0 is 0. I get 3x is 12. If I divide both sides by 3, my x is 4. So these are my 2 points. 0, 3, so left and right 0 and up 3, and over 4, and up and down 0. Okay, now my line is also going to be dotted, and I write that down so that I've got it all in front of me. And then for my test point, I'm going to test 0, 0 into this second equation. So that means I have 3 times 0 for x plus 4 times 0 for y is less than 12. 3 times 0 is 0, 4 times 0 is 0, 0 plus 0 is 0. And so I get 0 is less than 12. Is 0 less than 12? Yes, it is. So that means I am going to shade the point 0, 0 for that line. So I'm going to graph this line in pink so that I can keep them separate. I have 0, 3, and 4, 0. And I'm going to connect those points, and I know it's dotted, so I'm going to do my dotted line through those intercepts. And then I have to decide which side of the line I'm going to shade. I said I do shade to include that point, so I'm shading on this side of my dotted line, and it's everything on this side. But you have to be really careful of, your teacher's going to want to see all of the shading for both lines. But then what they're going to want to see is this part where they overlap. You see where the blue and the pink overlap? That's your actual solution. So either shade it in another color or shade it in really, really dark. And that what your teacher needs to see is the light shading to show that you knew which side of the line to shade on. But the dark shading shows where the two shades overlap. That's your intersection. Okay? And then I'll put where they intersect is the dark shaded overlap. And any point in this dark shaded area will solve both equations. So just to show you an example, if I pick a point in the dark shaded region, one of those points would be negative 2, 2. That's a point that's in the dark shaded region. Negative 2, 2. And if I plug it into the first, if I plug that point into the first equation, it should work. Plug in 2 for y is greater than 2 times my x value, which is negative 2 plus 3. 2 times negative 2 is negative 4. And I get 2 is greater than negative 1. That's true, so that point works in that first equation. And then if I plug that same point into my second equation, I have 3 times my x value, which is negative 2, plus 4 times my y value, which is 2, is less than 12. 3 times 2 is negative 6. 4 times 2 is 8. Negative 6 and 8 is 2. And 2 is indeed less than 12, so it checks in the other equation. So if you did that, every single point that's darkly shaded will be a solution for both inequalities. All right, so let's try another one. Okay, so for this one, first line, this is in slope-intercept form. My key features are my y-intercept is positive 2. My slope is a negative 1. Or negative 1 over 1 for graphing purposes. I have a line under my inequality, so this means this is going to be a solid line. If you have the equals, it's solid. And for shading purposes, I'm going to test my 0, 0. If I plug in 0 for y, I get 0 is greater than or equal to negative 0 plus 2. 0 is greater than or equal to 2. That is not true. 0 is not greater than or equal to, you kind of have to stop and think about it. Is it true or not? 0 is not greater than or equal to 2. That's not true. So I do not shade 0, 0 for that line. So I'm going to plot this. My y-intercept is positive 2. My slope is down 1 and over 1. I'm going to do that a couple of times. And when I draw this line, this is a solid line, so I can go ahead and connect all the dots. It's a solid line because of the equals. And then I have to decide which side of the line I'm shading. Okay, my test point is my origin 0, 0. And I said do not shade the test point. So that means I'm going to shade on the other side of the line from the test point. So for the blue, my shading is over on this side. Okay, for my second equation, I'm going to do that one in pink. This one's in standard form. In standard form, our key features is that we use our x and y intercepts. So I'm gonna plug in 0 for x and 0 for y. When I plug in 0 for x, I get 4y equals 4, divide both sides by 4, and y is 1. When I plug in 0 for y, I get 2x equals 4, divide both sides by 2, and my x is 2. These are the ordered pairs that I'm going to plot and connect. I have 0, 1, and then I have over 2, up and down 0. This one is going to be, there's no line under my inequality, so this is a dotted line. I'm going to test the point 0, 0. If I plug that in, 0 for x, I get 2 times 0 plus 4 times 0 is less than 4. I have 0 is less than 4. That is true. So I do want to shade the point 0, 0 in pink. So first let me graph the line. It is a dotted line through my two intercepts. Oh, I almost made it solid there. Okay, make sure it's dotted, make sure it's clear that it's dotted. And this time I want to shade on the side of that pink line where the red dot exists, where the origin is, because that was a true statement. And if you look, the only place where these two shades overlap is just this little triangle down here. So shade that really dark or another color. Okay, you want to see that dark shaded region. Your teacher needs to see the shades for each line, so you still have to have that part. Don't erase it or get rid of it. But really shade it in dark and make very clear that you know where that intersection is, and that's where the two shades overlap. Yeah, let's try another one. This one is in y-intercept form. So my key features are that my y-intercept is -2. My slope in front of the x is a 1. So that's going to be 1 over 1 for graphing purposes. I do not have any equals for my inequality, so this is a dotted line. I'm going to use my test point of 0, 0 to plug into my original equation. Plug in 0 for y is greater than 0 for x minus 2. 0 is greater than -2. I sort of have to think about it. Sometimes you have to do a number line just in your head to make it work. 0 is indeed greater than -2. This is true. So I do want to shade. So let's get it graphed. Notice I get all the things about it done first before I even get started to make sure that I get everything right. My y-intercept is -2. From that point, I'm going to go up 1 and over 1. It's a dotted line, so I'm going to connect my dots, but I'm going to keep it dotted because there's no equal to sign under the inequality. To figure out where to shade, I'm going to look at my test point, which is my origin. It says true, I do need to shade it, so I'm going to shade the side of the blue line that includes that point. So I'm going to shade this side because I want it included in my shading because it's true. And then I'm going to do the second line. This one is also in y-intercept form. So my y-intercept for my second equation is a +3. My slope is a -1/3. It has an equal sign, so this one's a solid line. And to figure out where I'm going to shade it, I test the point 0, 0. I have 0 is greater than or equal to -1/3 times 0 plus 3. That 0 is greater than or equal to 0 plus 3. Is 0 greater than or equal to +3? No, it's not. So I do not want to shade my test point for the second equation. Okay, so let's get it graphed first. My y-intercept is +3. From that point, I'm going to go down 1 and over 3. I'm going to draw a solid line. Okay, to decide where to shade, I look at my test point. My test point is below that solid line. It says do not shade, so I want to shade on the opposite side of the line from that. So I'm going to shade up here. And then I darken in my overlap. My overlap for that system is all of that. And so that's what you would overlap for your teacher. Okay, now sometimes, so that's if we did it from scratch. Sometimes we're going to have to look at something and decide what the inequalities are going to be. We're going to state what the intersection is. And the intersection is the point where the two lines cross. And we're going to write a system of inequalities for the overlap shaded region. Actually, let's go back to these others, because I don't think I actually did the point where they intersect. Let's just add that real quick. Here, on the first one, my intersection point was 0, 3. That was the point where the lines intersected. Okay, for my second one, they intersect at 2, 0. Where they intersect here at 2, 0. And for this one, they intersect at 3, 2. Okay, so you know, if they ask for the intersection of the two lines, make sure that you get that point. And the clearer you draw and the more accurately you draw your lines, the better, more accurate that point's going to be. Okay, so here it says state the intersection. My intersection of the two lines is +6, +2. It's over 6 and up 2. And we're going to write the system of inequalities. So I've got to figure out what these lines are. I'm going to first write the equations for the lines. For this line, I'm going to write an equation. I know I've got 6, 2 here is one point. I know another point I have is over 2 and up and down 0 for that point. So if I've got the point 6, 2 and 2, 0, if I'm going to write an equation for that line, I'm going to use slope intercept. I've got slope point slope. It's been a long morning. First I need to find my slope, so I'm going to do the change in y with the change in x. So I'm going to subtract my y's on top, 2 minus 0. Subtract my x's on the bottom, 6 minus 2. 2 minus 0 is 2. 6 minus 2 is 4. So my slope for this line is 1/2, and that's going to simplify. 2/4 simplifies to 1/2. Then I'm going to pick one of these points. I'm going to pick the first point. Y minus my y value, which is 2, equals my slope times x minus my x value, which is 6. I'm going to distribute the 1/2. So I have y minus 2 equals 1/2 x. 1/2 times -6 is a -3. It's 6 over 2, which simplifies to 3. Add 2 to both sides. So my y-intercept equation is y equals 1/2 x minus 3. Or excuse me, minus 1. It's -3 plus 2 minus 1. I have to decide whether this is greater than, less than, or equal to. Now I know it's going to be an equal to sign. My point here is my intercept. I'm going to test 0, 0, and it should work. So if I go 0 is 1/2, 0 minus 1. Okay, what I'm doing is I'm taking that test point and I'm plugging it into my equation. I have 0 and 0 minus 1. What inequality works here to make this true? Because I want it to be true because it's in the shaded area. This is the dark part here. So we shaded above the line and we shaded where that to include that point. So if I want to include that point, I need an inequality that's going to make this true. And -1 is less than 0, so 0 is greater than -1. And it's a solid line, so it's going to be an equal to sign underneath it. So my final equation is going to be y is greater than or equal to 1/2 x minus 1. That's the first equation. Okay, the second equation is going to be this dotted line. And for that one, I've got a horizontal line, which is HOI. Okay, whenever I have a horizontal line, it's a y equals, and this y, it crosses the y-axis at +2. So it's either going to be y is greater than 2 or less than 2. And so I've got to figure out what my inequality is. So I'm going to test the point 0, 0. And in this graph, this dark region's down here, so I graphed below the line. And when I graphed for this dotted line, I included that point. So I need to make something that's going to be true here. If I plug in 0 for y, to make that true, it'd have to be 0 is less than 2. If I put 0 is greater than 2, that's not true, so that's not going to work. I want it to be true because I included that point, so y must be less than 2. That's going to be my equation. It's kind of working it backwards, which is kind of bizarre. All right? And so we wrote a system of inequalities. Our system, if you wanted to write it all together, is y is less than 2, and y is greater than or equal to 1/2 x minus 1. Okay, this is working it backwards. Okay, so let's look at the next one. On this one, I'm going to do this equation first, and that's my vertical line. So if it's a vertical line, that's Vux. So I know it's going to be x equals, because vertical for Vux, and it looks like it goes through at -3. So the line is x equals -3. I need to decide whether it is x, and it's a dotted line. So it's either going to be x is greater than -3 or x is less than -3. It's going to be one of those two. I shaded, this looks like this is the dark region, which means they shaded on this side of the solid line, which means they included that test point. If I take the test point 0, 0, and I plug in 0 for x, I need the inequality that's going to make that true because they shaded to include it. Well, if I make this true, 0 is going to be greater than -3. So that means I'm going to use x is greater than -3. And because it's dotted, I don't use the inequality there. So this is my equation for that vertical line and its shading. Now I'm going to do this line and its shading. And looks like it goes through 0, 0. It also looks like the intersection was -3, 2. That was my intersection. So I'm going to use that point. And it goes through the origin at 0, 0. So I'm going to use point slope. So I'm going to find my slope first. You take your change in y or your change in x. So I'm going to subtract my y's. 2 minus 0 for my y's. -3 minus 0 for my x's. 2 minus 0 is 2. -3 minus 0 is -3. So my slope is -2/3. I'm going to use this point. I'm going to use my 0, 0 point. Y minus my y value, which is 0, equals my slope, -2/3, times x minus my x value, which is 0. So I have y equals -2/3 x. Okay, so the equation of the line is y equals -2/3 x. I've got to figure out, this is a solid line, so it's either going to be y is greater than or equal to -2/3 x, or y is less than or equal to -2/3 x. It's going to be one of those two because it's an inequality. It's equal to because we've got the solid line. I need to put a test point that works. Now I don't want to use 0, 0 because it's on the line, so I'm actually going to use the test point 1, 1. I'm going to test 1, 1. And it looks like on that one, they shaded below, so they would not include that. So I need to see that that does not work. So if I plug in 1 for y and 1 for x, I get 1 on one side and -2/3 on the other side. And I want it to not work because it's not shaded. So if I put y as 1 is greater than -2/3, that would work. Y is less than -2/3 doesn't work. So that's the inequality I want to use for my equation, is y is less than or equal to -2/3 x. And so my system is x is greater than -3, and y is less than or equal to -2/3 x. Okay, so you want to create the inequality that's not going to make this one work, but it does make this one work because we shaded to include that particular test point. Okay? All right. And that's as far as we're going to go for today. Really, if you need to go back over number 4, A and B, those are probably the ones that are going to be the most challenging. Take the time to do that. And what you're doing is you're working backwards to create the equations.